What's up, guys? Welcome back to the channel. So now that we've got our environment up and running, it's time for us to start building out some of the core components before we dive into setting up our application. And first on the list is our DNS server. So there's this classic joke that says it's always DNS, not unless it's DHCP, but it's usually DNS. And that's because DNS is the one service that touches almost everything in your environment. It's like, you can look at it like the phone book for your environment. Without it, nothing knows how to find anything in your environment. Running your own DNS server isn't just about performance, it's also about privacy, because when you keep your DNS query local, you're not handing over data to public providers. In today's video, we're setting up BIND9. BIND9 is a powerful open source DNS server. And sure, I know there are easier tools like Pi-hole or Unbound, but the reason why I choose BIND9 is because BIND9 gives you full control and help you truly understand how DNS work. We will have to configure everything manually, and that's the point. It forces you to learn things that make DNS work, and that is one of the main reasons why I chose it. As always, chapters are below, so please feel free to jump to whatever part you want or whatever part interests you the most. With that being said, let's go ahead, let's get started. So before we jump into the setup, let's first try to make sure we understand what DNS actually does. DNS stands for Domain Name System. It's what translates easy to remember names like, let's say, google.com into IP addresses that machines use to communicate. So like I said earlier, think of it as your network's phone book. So if you refer to services by name, again, example, google.com, DNS is what resolves that name to the actual IP of what you're trying to reach. Without it, the system can still talk using just the IP, but that's not scalable or user-friendly. So whether you're accessing a website, internal tools, or automating tasks, DNS play a key role in keeping everything connected and working smoothly. All right, so we're going to set up BIND9 inside an LXC container. I'll be using LXC containers for all my core services, so things like DNS, certificate authority, and more stuff down the line. So if you're not familiar with what an LXC container is, please check out my Proxmox core component video. It pretty much breaks down all you need to know about LXC containers and other components of Proxmox. So make sure you check that out. Link is in the description box below. So let's go ahead, let's move on to step one, setting up the LXC container for our DNS server. Okay, so the first step to setting up our BIND9 DNS server is to make sure we have our LXC container up and running. So an LXC container is basically just a lightweight mini virtual machine without the overhead of a full VM. And the first step in setting up our LXC container is that we want to download a container template. And to download a container template, we need to pull it into one of our storage. And these are all the storage that we have here. Now, your storage might be different depending on how you set it up. If you do want to, walk through of how to set up or configure Proxmox storage, I do have a video on that as well. So link will be in the description box for that as well. So we're going to go into one of our storage. In my case, I'm going to go to Sandbox because this is the storage that I want to pull the container in. The template in. So we're going to go to our Sandbox. We're going to go to CT template, and then you can either upload the template, you can either download it from the web, or you can pull down one of the template that's already predefined in Proxmox, pull it down, and then bring it into your storage, which is a lot more quicker. So in our case, we want to pull down a Ubuntu template, right? Because we're going to be installing BIND9 on our Ubuntu VM, well, Ubuntu container. So here, we want to select the version that we want. So in my case, I'm going to go ahead and say 25. I'm going to go latest. I think 25 is the latest. So 25.04 standard. I'm going to go ahead and select that. And I'm going to go ahead and select download. What that's basically doing is that it's going to pull that down into our storage so we can use it during the setup phase for our container. So just give it a couple of seconds. Once it's all good, it's going to say task OK. And I'm going to click X, and now we should see that template right here. So now the template lives inside of our CT template section in our storage. So the next thing that we need to do after we pull down our CT template is that we want to go ahead and kick off the creation process for the container. So here we're going to go ahead and click on create on the top right hand corner. We're going to go ahead and click on create CT. That basically just means create container. And then, of course, create VM just basically means create VM. So we'll click on that. It's going to give us this box. The first thing is going to ask you, like, hey, what node do you want to install this container on? We only have one node, so node 0. And then here you have the ID. You just can leave this to auto-populate because it kind of increments based on the things that you're creating. So 100 is the first one, 102, and so on and so forth. The host name, you can call this whatever you want, but it's always ideal to make the host name very similar to the service that you're going to install on the container. So in this case, we're going to say this is a DNS test, right? And then you have unprivileged container and nesting. You have two of this box check. I'm using unprivileged container because it maps the container's root user to a non-root user on the host. So even if the container is compromised, it can't affect the host. If I was to uncheck this, for example, what will happen is that if the root user on the container, especially if you're going to make this container front facing, meaning that you're going to try to access it from outside of your internal environments, like out on the web, and you don't have kind of like the right security in place, if you were to uncheck this, right, and the root user on this container also has root user privilege on your host, which meaning that the Proxmox host, this guy right here, node 0, that's going to be a huge problem because now they can do whatever they want. So it's always good to check this. A lot of people uncheck this box because there's a lot of issues that you can run into when you're running an unprivileged container. But I always say, in my opinion, always try to figure out that issue outside of just unchecking this box. Right. So I'm going to go ahead and check that. And then here you have nesting. So basically, I enable nesting. I normally enable nesting on the things that I set up because what that means is that the container allows you to run full system service like DNS or systemd. So basically, it lets the container act more like a normal Linux system. I hope that makes sense. So these two things you definitely want to make sure you check that, especially if you're going to install things like DNS on this container. And then for pool, the resource pool just allows you to group things together for permissions and other things. In my case, this is a test. So this is test lab. So I'm going to go ahead and select that. And then password, you can make this whatever you want. This is just a test. Again, I'm just going to make it something simple. But in your case, if you're setting up a real DNS server for your environment, for whatever it is that you're setting it up for, just make sure the password is really strong, right? So let's go ahead and enter that. And then here you have the SSH public key. So basically what this lets you do is that it lets you add an SSH public key to the LXC container. So you can have SSH access from the start. I can never say SSH for some reason. If I try to say it too fast, something else comes out. But anyways, it allows you to have SSH access from the start, and you can log in without password using your private key. Now, we are going to enable SSH because we want to be able to SSH into this container to be able to make some of the config changes. It's just a lot more easier to make config changes on something like, let's say, VS Code than do it in the terminal. The terminal is a lot more harder when you're presenting something. So we're going to enable that. But for now, we're not going to use any SSH public key. Right. So once that's done, we're going to go ahead and click next. And then here it's asking us, what template do you want to use for this container? So if you remember, we just pulled down the template. We did install it in the sandbox. So we're going to go ahead and say sandbox is our storage. And then we're going to select that template that we just pulled down. Go select that. And then go ahead and click next. And then here it's going to ask us like, hey, what storage do you want to use? Now, this is a DNS server. You don't need a lot of storage. So something like 8 gigs works just fine. But if you feel like you're going to need more, you're going to do more stuff, you can do 10 gigs or you can do 50, whatever it is that you want. Just be mindful of the storage amount that you have. And then here, I'm not putting this in a local. I'm putting this in a sandbox because, again, this is my test environment. Everything goes in a sandbox. So I'm going to go ahead and select the storage that we want to use. And then we want to say we want to give it just 10 gigs. And again, this can be lower, again, because this is a DNS server. You don't require a lot of space, right? And then next, we're going to go to CPU. Here again, DNS server don't require a lot of like cores, but make it 2 or 3, whatever it is that you want to make it. Just be mindful of your resources on your Proxmox node, right? So I'll make it 2 for now. 2, right? And in memory, same thing. This is perfectly fine. This is perfectly fine. But if you feel like you need more, which again, that sounds like a broken record, it's a DNS server. So this is, I'm gonna just increase it a little bit, just for increasing its sake. But you don't necessarily need this much because again, this is just a DNS server. Gonna go ahead and click next, and then the swap memory as well. Right? Again, this is perfectly fine. Gonna go ahead and click next, and then here for networking, I'm gonna switch this guy right here. We're going to use our SDN. So we're going to use our test environment. Again, if you don't know anything about like Proxmox networking, setting up SDN, all this other things that you have to set up to kind of make sure, like VLAN and all this other cool things you have to set up to make sure that your environment is isolated, especially when you have a test environment, especially when you're doing a lot of things on YouTube, like I'm doing right now and presenting things. You want to isolate things because as much as we like to think that we're super careful, you need to be very careful in terms of isolating the things that are public facing, whether it's a video or anything like that, because we all make mistakes. So in my case, the VLAN 100 test is kind of like my test in VLAN. It's isolated from the rest of my network, so on and so forth. And if you want to see how to do that, of course, I have a video about that as well. I will add that in the description, or you can just check out my channel. So I'm going to go ahead and do that. I don't have to add a tag because the tag is already added at the SDN level. So I don't have to add anything here. And then here for networking, you always want to make your core services in your environment static. You want to give them a static IP address because something like DNS, you don't want the IP address to be changing all the time. So you definitely want to make sure the IP address on your DNS server is static. So in that case, it's going to be 10.10.100. Let's do 3 /24. All right. This is kind of our subnet for this VNet. So we're going to go ahead and do that. And of course, the gateway is 10.10.100.1. All right. And then for IPv6, don't worry about that. So now we have our static IP. We have our bridge, our SDN selected, and then we're going to go to DNS. And in this case, this is the DNS server. So if you do not have a DNS server already set up in your environment, which if you're setting up your DNS server, you don't, you're going to leave that blank, but you can always update this after it's done. Go ahead and click next. And then we're going to look at the summary here. And then we're going to say, okay, you can start the VM once it's created. And then we're going to go ahead and click on finish. So once that's what that is going to do is going to go ahead and create the VM for the container for us, not the VM. So I use the creating VM. I call everything a VM. So once you see task OK, that means that it has completed. So we're going to go ahead and X out of that. And now if we go to LXC right here, we're going to see that our LXC container is up and running. And we're going to see all this information about our LXC container. And the first thing I like to do when you're setting up, again, the core components of your environment, you want to make sure that every time your server restarts, you want to make sure that the core components for your environment also start with that restart, right? So because if DNS is very crucial for your environment. If your DNS is not working, you can't reach a lot of things with their FQDN, meaning that they're fully qualified domain name. You're not going to be able to reach that because there's no DNS server to be able to tell your computers like, hey, this IP address is belongs to this name, this FQDN. So you always want to make sure that when your server is turning on, we're going to come, let me go back. You're going to go to option, and then we're going to go to start and boot. We're going to say yes, because you always want to make sure that when the server reboots, your DNS server comes back up, because if it don't, well, a lot of things are not going to work in your environment. It's always DNS. So once that's done, we want to go to the console. And the first thing that I'm going to like to do is I want to first make sure that I have internet, and then second, just kind of run a regular update on the VM. So here we're going to log in. So whatever password that you choose. So there's root, right? And then that, and then now we're in. And then I'm going to do just really quick, just to make sure I have internet. And then we can see we have internet. That's perfect, right? So I ping Google just to make sure that it can go outside. And as you can see, we have internet. And now I'm going to do apt update, all right? And then we're going to do and apt upgrade -y. So basically what we're doing here, we're telling it like run an app update and then run an app upgrade. And then -y basically just means that say yes to any prompt that comes up that's asking me to say yes, or no. Click enter. It's going to do its thing. All right. So once that's done, we can go ahead and move on to the next step and start installing BIND9 on the LXC container we just set up. All right. So now that we have our LXC container up and running, we're going to move on and install the BIND9 server along with all the tools we need to manage it. Let's go ahead and get that started. All right, so let's go ahead and install BIND9 on the container. To do that, we want to do apt install BIND9, and then we also want to do BIND9 utils, and then we want to do BIND BIND9 docs, and then -y. So basically what we're doing here is we're installing BIND9, we're installing the utilities for BIND9, and then we're installing the docs. You don't necessarily need the docs, but well, you need the docs. But you can leave that out if you don't want the docs. So click enter. So what's going to happen, it's going to go through, do its thing, pull that down, and then once that's done, we should now have BIND9 set up and install on this server, on this container. So there you go. So now we have BIND9 fully installed on the container. So now if we were to cd into the BIND9 folder that was created during the installation, we should be able to see all of the config files that we're going to need to make changes to. So to do that, we're going to do cd, and we're going to say etc, and I'm going to say bind, and then I'm going to click enter. So ls, now you can see that these are all the config file that we're going to need to make changes to be able to configure and fully set up our DNS server. And by the way, if you do pwd, this will give us the path. So to be able to find this config files, you will need to go into etc and then bind to be able to find all of the config files. I'm going to do ls one more time. So as you can see, these are all of the config files, and we're going to talk about what each of these means in a minute. But these are all the config files that we're going to need to make changes to. Next, we're going to make sure the bind user and group have the correct permission on all the bind configuration and data folder. That way, bind can read and write to everything it needs without running into permission errors later. Let's go ahead. Let's take a look at that. There are a couple of permission changes that we need to make on some of the folders because we want the bind user and the bind group to be able to own some of those folders so they can make the changes that they need to make to those folders without any issues. Because if they don't have the correct permission to some of the folders that they need to have permission to, when you try to make changes to specific config file and all this other stuff, if the bind user or the bind group is the thing that's making those changes, then you might run into some permission issues if they don't have the right permission to those folders. So one of those folders is the folder that we're currently in. So if we were to do pwd, for example, we're currently in the bind folder. We want to make sure that the group, the user and the group of this folder is the bind user and the bind group. So to check that, we want to do cd ... That will take us one level back. And if we were to do ls, it will give us all of this, but we don't want to see all of this. So to do that, we want to do ls-la, and we want to pipe that into grep. And then we want to say bind, because that's what we're looking for. So what that is going to do is that it's going to just show us anything that have bind on it. So as you can see, currently the user is root and then the group is bind. However, we want to make sure the user and the group for this folder are both bind, right? So what we want to do is we want to do ch on, and then we're going to do r, and then we want to do the user is bind, so bind, and then we want to do colon, and then we want to say the group is also bind, so bind, and then we want to say that we want to update this particular folder, which is the bin folder, right? Or the bind folder. So etc, etc, bind, and we click enter. So now if we run that command again, we should see that now the user is bind and the group is bind. So that's what we want. So another folder that we need to make changes to as well is the cache folder. So that similarly, we're just going to, I'm just pressing the up arrow to give me the same command because I don't want to retype it. So we just want to change the path here. So same concept, we're just changing the owner. So we're just going to go here, and that is in the var, and then cache, and then that is the bind folder. So we want to change that as well. So same thing, ch-own -r. R just basically means recursive since it's a folder. So kind of go in there and change everything in there. Kind of make sure the change is recursive, meaning that it applies to the folder and everything in the folder. So we're going to go ahead and click enter. And that's done. And then another thing that we want as well is that if we plan to log some of the things that are happening in bind, we need to create a log folder in the var folder, and we need to change the owner of that as well. To create that folder, all we want to do is we want to do mkdir, and then we want to say -p. -p basically just means that if when you're going through the path of creating the folder where we want you to create it, If any of those folders don't exist, please create it, so to speak. So we're going to do var because we wanted this to be in the var, and then we want to do log, and then we want to do bind. So basically what we're telling it is that create a folder and then put that folder in the var, and log, and create another folder called log, and then in there do bind if the log folder doesn't exist. If any of those folders don't exist, which those two should, then create it as well, and that's what the -p is for. So once we do that, we're going to click enter, and now that folder should exist. So now we're going to do the up arrow, right, to take us back to changing the owner, and then we're going to go back, and we want to say log, log, and then we want to do bind, and then enter. So now the owner of that folder has been changed, so we should be good to go. So those are the three folders that you need to change permission to, one of which is this guy, and then the other one is the bind folder in etc, one is the cache, the bind folder in cache, and then one is the bind folder in the log. So I'm going to go through this one more time just so we see it. So one of them is this guy, right? It's showing me a lot of stuff. So one of them is this guy, right? And then if we go back up one more, right there, that's creating that. And then one of them is this guy, right? The cache bind. And then the next one, of course, is the bind in etc. So we're changing the owner for those three folders. And the reason for that is that we want the bind user and the bind group to be able to make changes to those particular folders. Okay, so I want us to quickly break down the bind files we'll be working with on this config. There are a lot of files in the bind folder, but I'm mostly going to talk about the ones that we're going to touch on this configuration. You can always go back and look at some of these other files, but for now, let's focus on the ones that we're going to be touching throughout this config. First is the name.conf.local file. This is where we'll define our custom zones for forward and reverse lookups. Next are the DB files. These files hold the actual zone data, so things like the A record and the PRT records. So what we'll do is that we'll copy some of these as the starting point for our zone files. And finally, we have the db.root file. This file will store our root hints, so bind knows where to begin when performing recursive lookup. And this is something we'll have to create. So like I said earlier, there are a lot more files in the bind folder, but these are the main files we'll touch to get our DNS server up and running. Before we create our forward zone, let's first talk about what that is. A forward zone is where we map names to IP address. So if someone look up something like server.testlab.local, DNS will return the IP. The most common record here is the A record, which links a host name to an IP address. There are other record types like CNAMEs for alias, MX record for mail server, TXT record for text-based data, but our main focus today is the A record. Another thing that we have to clear up is the difference between an internal and a public DNS. An internal DNS handles names and zone for devices inside your network, while public DNS is used to resolve names on the internet. If you point to a computer to a public DNS or any DNS that isn't aware of your internal zone, then it won't be able to resolve the names for your local resources. Now that we have a good understanding of things, let's go ahead and let's set up our forward zone. All right, so in order for us to create our forward DNS zone, we first need to define our custom zone, which is kind of like our domain name. So to do that, we want to cd into our bind folder, right, and then ls. And this is where we're going to need to make the configuration change. This is where we're going to need to add our config for our zones, right? So here you can do something like nano, if you have nano installed, and then name.config.local. And if you want, you can make changes to this file directly in the terminal. In my case, I'm not going to do that. I'm going to use VS Code to be able to SSH into this VM and make the necessary config to this specific file. So just keep in mind that if I was to do something here, add a change to it and do Control X, it's going to ask me down here, do you want to save it or do you not want to save it? I'm going to say no. And if I was to go Control, if I was to go back into it, you're going to see that no changes were made. So if you do want to make changes to it in the terminal, you can do that here. But in my case, I'm going to use VS Code, SSH into the container and be able to make changes because it's just a lot more cleaner. Now, keep in mind that for you to be able to SSH into the container, you have to make sure SSH is enabled. And if you guys don't know how to do that, or you need help with that, I can create a short video about that. It's pretty straightforward. I can create a short video about how to SSH into the container. But for now, we're going to use VS Code to make the config changes because it's just a lot more cleaner. But I just wanted to show you guys in the terminal that this is the file that we're going to be working with for our zone configuration. So as you can see, we have now SSH into our container. This is the IP of our container, and I'm using VS Code. Again, you can use whatever SSH tool you want, but in my case, I'm using VS Code because I like VS Code. If you do want help in terms of how to SSH into a container, again, leave a comment down below and I'll try to create a quick video about that. But when we're SSH into the container, I'm going to go ahead and say open file, and it's going to take us directly, well, maybe it might not take you directly into the bind folder, right? But if it takes you to somewhere like etc, or it takes you to somewhere like home, you just want to click on etc and then you click on bind, and then it's going to take you into the bind folder. Now, these are all the things that we have in the bind folder, but this is the file that we need to work on. So again, you can click on this and it will take you into that file, or you can do it like I showed you guys earlier in the terminal and make that config changes in there. So the first thing that we need to do is we need to define our custom zone. And to do that, what I'm going to do is I'm going to copy this config over, and this is why I'm using VS Code, because it just makes it a little bit easier. We can get rid of all of the other stuff there. So we'll do Control Z here. These are all just regular comments. So these are just comments here, so we don't, you can remove them. There'll be no issue there. And we're going to paste in our first initial config. So this is basically defining our zone. The first thing that you see here is defining what our zone, so technically what our domain should be called. Now you can call this whatever you want. So in this case, it's lab.local, but you can call it something like, let's say, ktech lab.com or something like that. You can call it whatever you want. Again, this is your zone. You choose to call it what you want to call it. And the second line that you see says type equals master. Basically what that is that it's saying that the server is the authoritative source of data for this zone. So this is the master zone, so to speak. Then next you have the file. The file, the etc bin db.lab.local. Basically, this is telling bind where to find the actual DNS record. We haven't created this yet, and we'll create this soon. But just leave that like this for now. We're going to change this once it's created because this haven't been created yet, but we'll create it later. And then here you have allow dash updates, and then it says none. Basically, what that is saying is that there is no dynamic updates allow, because again, we're not doing dynamic DNS for this configuration. I'll talk about that a little bit later. But this is basically what this is doing. This configuration here is basically just defining your zone. It tells the DNS server what you want your zone to be called. You're telling it that, hey, this is the master, and then you're telling it that, like, hey, this location is where you will find all of the DNS record that I'm going to set up for this zone, right? So once you have this set up the way you want, and just for organization's sake, we're going to also call this ktech, where is it, ktech right there. We're going to call it ktech lab.local as well, .com, not .local. I'm going to call this ktechlab.com because our domain is called ktechlab.com. Again, once we create this, you're going to see what we're talking about. Again, this is where I don't want to sound like a broken record, but this is where our DNS record are going to live. We're going to create it after this setup. So once you have everything like this good to go, I'm just going to go Control S. Control S basically just save it. So if I was to switch back to the terminal now, so I'm going to go ahead and switch back to the terminal. So now I'm back at the terminal. So if I was to do ls again and then just do cat name.config.local, you can see that that config file is now in there, and we're saying that, like, hey, this is what we want our zone to be called, and all of the config that we made in our VS Code editor is perfectly fine here. And this is the first step that we need to do. The next thing that we need to do is we need to create this file, because in our configuration file, we're telling the bind config that, like, hey, this is where you will go to find where our actual DNS record lives. And if you look up here, this file doesn't exist yet, and we need to create it. And to create it, we need to copy this file because this is the default DNS record config file that comes pre-configured with bind, but we don't necessarily want to use that. So we need to copy it. So if I was to do cat, for example, db.local, you can see that this is the default one that comes with it, but we need a copy of that. We don't necessarily need to use that exact one. So to do that, we just want to copy db.local, and we want to call it this guy right here, because this is, again, this is where, or this is the name that we put in our config file, and we want to make sure it matches, because again, this is what the config is going to look for your A record, right? So we're going to go ahead and click enter. So now if we do ls, we can see that that file now exists if you look at it right here. And if we do cat db.k, you can see that it just copied exactly what was in the db.local file, and that's exactly what we need. Now, again, you can make config changes to this file here, but I'm not a big fan of making config changes to it in here, no, unless it's an emergency and I really have to. So I'm going to switch back over. Again, you can just do nano, and then you say db.k, and then you can go down here and then change things, and then just do Control X, and you can save and get out. But we're going to switch back over to VS Code and make changes to ls and make changes to this guy right here. All right, so now that we've configured our zone file, we're going to go in here back at home. We're going to go to open file, and what we're looking for now is the one that we just set up with, is this guy right here. So we just set up the dbktechlab.com. That's what we call our zone file. So we're going to click on it, and it looks something like this. So what I'm going to do is I'm going to replace this guy here with something similar, just a little bit different. This guy right here. So basically what you're looking at here is kind of like the zone file for the zone that we just set up. So what we're telling it is like, hey, time to leave. So TTL, which you see right here, basically this sets the default time, right, to leave for all the record in this zone. And then you have something like the SOA here, which basically just define who is the authoritative for this particular zone. And in this case, this is our DNS server name, right? So remember, we'll call our DNS test. And then, of course, DNS test, we have our new domain or a new zone, which is koromatech.com. And then here you have something that is supposed to be the email for the administrator that is managing the zone. But this is not a real email. But in your case, you will have to put an email here for the administrator that's managing the zone. And then you have something like the serial number. The serial number basically it just increments. It's basically an increment every time you update the zone, or every time the zone is updated, this get incremented. But most of the time when you're doing it by yourself, you can either put 2, 1, and change it manually, because this is manually being changed and manually being configured when it's not a dynamic DNS, so you can make those changes. And the rest of this record that you see right here, from here to here, these mostly just have to do with the secondary DNS. So if you have something like a backup DNS that is set up, so in case your primary DNS goes down, these are kind of the configuration for the expiration, retry, and refresh rate for that particular DNS when they are communicating with your main DNS here. And then this guy is basically the TTL for the field lookup. So it's like a cache configuration for TTL for a field zone lookup. And then if you move down here, this basically just say what the authoritative, I can never say that word right, what the authoritative server is. And again, our authoritative DNS server, and the accent is kicking in, the authoritative DNS server is, of course, our DNS server here, DNS test. Again, that's the name of our DNS server that we created, and the domain ktechlab.com. And then here is the main record, or the only record that we have on this configuration on the zone file so far, and it's an A record. So this is what I was talking about. This A record is one of the main record when it comes to setting up a DNS server, especially internally, because for the most part, you're going to be mapping your host name to an IP address. So basically, that's what we're doing here. Again, the name of our container or server, whatever you want to call it. Our DNS container or DNS server is DNS test. And then the IN just means that it's an internet class. And then we're saying that we want to set up an A record. And of course, we want that A record to be tied to this IP address. So basically what we're doing here is that we tie in this name, so this server, DNS test, to this IP address 10.10.100.3, which is basically our IP address for our DNS server. So this is where your DNS server will look to be able to find things. So when you do something like ping DNS test, it will look in here to try to see if this A record exists. And if it exists, it'll come back and say like, oh yeah, I know this A record, and this is the IP address that's associated to this A record, which is this guy right here. Now what we want to do is we want to save this, turn on or enable the BIND DNS, and then test a couple of things and make sure that our zone that we just set up is working, and DNS server is able to look at our zone file and be able to see our A record that we just set up in our zone file. So I'm going to go ahead and click Control S. In your case, of course, if you do a nano, you can do Control X and then save. And then I'm going to go back to the terminal and we can test some things there. All right, so before we start testing things, the first thing that we want to do is we want to enable BIND9. So to do that, we want to do a system CTL enable, and then we're going to say named. Click enter. It's going to enable it. And then now we're going to do a system CTL start BIND9, and then we're going to do system CTL, leave that there, and we're going to say status status BIND9. So as we can see now, BIND9 is up and running. So that's the first thing that we need to do before we even start configuring or testing some things. You can also try to restart as well, restart BIND9 just to be safe. So you can do something like systm CTL restart, because most of the time after you make some changes, you want to restart the services. So BIND9, and then it's going to restart it. And then we're going to do status one more time just to make sure it's up and running. status. All right, it's up and running. So the next thing that we're going to do is that we're going to try to see if we can send a query to our local host, which is the DNS server that we're running on right now, to try to see if we can query our domain name from our DNS server, the domain or the zone that we just set up, the domain name zone, whichever one you want to refer to, that we just set up. So to do that, we're going to use the dig command, so dig, and then we're going to say at CL host, which is basically this computer, and we're going to say, what is that domain key? chlab.com. All right, and then click enter. And as you can see, it comes back and say like, yes, I'm able to find something for that domain. Everything looks good. So if it comes back something like this saying that it's able to find it, everything is good, it gives you the time, everything looks good, and it say here, yes, there's an A record for that. So that means that our domain is working good. Our configuration changes that we just make. So let's do ls one more time. So our configuration changes that we made to this guy, which is our zone file, and of course our, where is it, name.config.local here, the zone that we just set up here is working correctly. Now, one of the things to keep in mind is that when you set up a new server in your environment, it will usually get its DNS settings from whatever is pushing them down. So like your DHCP server. Now, if you want your new server to use your new DNS server, in our case, the test DNS that we just created, you will either have to update your DHCP configuration to push the new DNS IP down, right? Or you will have to manually set the DNS server on each individual machine. In today's demo, we're going to set it up on the individual machine. So to see what DNS server is currently being used by this machine, what we want to do, and again, this will be, in my case, the firewall is pushing it down. So you're going to do cat etc. We're going to look at the folder resolve.conf conf conf. All right, we're going to look at the folder or the file that is basically going to tell us what DNS server this machine is using. So in that case, right now, what is being pushed down is 192.168.1.1, which is the firewall, so to speak. So it's just pushing down the DNS server that's set up at the firewall level. So we don't want that. And then remember, when we set this up, right, we didn't set any sort of DNS whatsoever. So what we want to do is it's going to ask us like, hey, what is the DNS name? So our DNS domain name is, well, the zone that we just set up. So it's KTech lab.com. And then it's going to ask us, what is your DNS server? Now, you can either enter the FQDN of the DNS, or you can just enter the IP. So the IP is 10.10.100.3.3, right? And then we're going to click OK. Right. So now if we go back just to make sure here, 10.10.103, if we go back to our DNS, we're like, hey, this is our domain name and this is our DNS server. This is what you need to look at. Now, if we go to console, right, and we go to look at it again, it's not going to work because most of the time you most likely have to restart the server. So as you can see, it's still pointing to that guy. But if we were to do a reboot, all right, wait for that guy to come back up. It's going to take a couple of seconds for it to do the things. Containers are pretty fast in terms of like startup. They're extremely fast, actually. See, it's back up already. So root, right, and then enter our password. All right, and then if we go back up here, you can see now it's looking at our DNS server. So that's perfect because now it's like, okay, well, I'm looking at your new DNS server. Everything is good to go and everything is fine. So now if we were to ping, and we're going to add a different VM to it to just kind of highlight that, but we'll add that a little bit later. If we were to ping just the host name, so PING, let's say, what is it? DNS test. It should be able to ping back. So as you can see, it's pinging back to say like, hey, the name here is DNS test .ktech lab, and then that's the IP address. So a DNS server is this, you can see how a DNS server is kind of the core thing in your environment. Reason being that once you start setting up different services, different servers, different container, all of them are going to have an FQDN. They're going to basically have this guy right here, which is referred to your FQDN, which is a combination of the server name and the domain name, which is your fully qualified domain name. So you're going to refer to everything by its FQDN, right? So in that case, your DNS server is very important because your DNS server is where all of them, I'm going to control XC out of this. Your DNS server is where all of this information is stored. So you can imagine that when your DNS server goes down, everything in your environment goes down. Even if they're working, that goes down because a lot of configuration changes, a lot of the config file that you're going to set up are all going to refer to something's FQDN, their fully qualified domain name. So now we have our zone set up and we have our zone file set up, and that part is good to go. So this is kind of like the first part, which is the forward zone. And this is how you set up a forward zone for your BIND9 server. The next thing we have to set up is the reverse DNS zone. A reverse zone does the opposite of a forward zone. It maps an IP address to a host name. So instead of asking what IP address is something like server.testlab.local, you ask who owns this IP address and get the name in return. This is really important for things like login, email servers, and security tool that needs to verify where traffic is coming from. Just like a forward zone, reverse zone use special records. The most common is the PTI record, which maps an IP to a name. In my lab environments, I'm going to set up a reverse zone so we can properly resolve our private IP address back to their host name. All right, so to create our reverse lookup zone is very similar to the way we went about creating our forward zone. So to do that, let's do ls here. So we'll do ls. To do that, we're going to need to edit this file. And then 2, we're going to need to create something similar. So we're going to need to create a zone file, something similar like we did for the forward lookup zone, right? We're going to need to create a zone file. But first, we need to make some configuration changes in this guy. So we're going to go ahead and say nano. And it's this one is a pretty simple change. So I'm going to do it here. And then for the zone file, we're going to go into VS Code and make that change. So we're going to do nano named .local, right? So as you can see, we have our forward zone set up here. So the next thing that we need to add, we just need to add our reverse zone. So I'm going to go ahead and just move down a little bit here and just put that guy in there. So this is our forward zone and this is our reverse zone. So our reverse zone, the name of our zone is 100.10.10, and then you have the .in.addr.a RPA. And then type master, so very similar. And the location for our zone file is going to be this guy. We need to create this guy. We haven't created it yet. And we're going to do something similar to keep things organized. We're going to say like, hey, this is for this particular subnet, and the 10.10.100 helps us keep things a little bit organized. And then, of course, allow updates, so dynamic DNS is turned off. So again, very similar. One of the things to keep in mind is that if you notice, this zone name start 100.10.10. The reason for that is that reverse zone use the IP address backward, because that's how DNS organize and delegate address under the reverse zone hierarchy. So you're going to notice that when we go to create our zone file and when we update our zone file, you're going to notice that all that we need in that zone file is the last number of our IP address, because when you do a reverse lookup, the way it works is that it basically just take that number and then it looks at it, it puts it in front of here. So it's going to be 3.100.10.10. So it goes backwards. And that's why it's set up this way. This is why our zone name is like this. So that's pretty much good to go. That's all we need to do. That's the first step that we need to do for our reverse lookup, very similar to what we did for our forward lookup. So Control X, I want to save it, yes. And then if I do one more time, it's in there. So we're good to go on that end. Now, ls, what we want to do is we want to create our zone file. So again, similar to what we did here. And for that, we're going to copy this guy. So if I do cat db dot, what is that, 1, and we're going to copy this guy, right? So it's a default reverse data file, zone file. And of course, we don't want the default. We want to create a new one. So let's go back in here real quick. Let's see what we called it. So I'm going to do cat, I'm going to do name.local, and we called it this guy. So what we need to do is say cpdb.1 tab, and then we want to call it this guy. So basically we're just copying this guy and we're going to rename it to this guy. So enter. Now if we do ls, now we have our zone file created. If we were to do cat, right, db.10, there you go. We have our zone file now created. So now our config, so cat one more time, name.local, our config file now exists. So do not forget to create this zone file, because this is the zone file that's being pointed to in the config, right? So now that we have our zone file, we're going to go ahead and make that config changes in VS Code. Actually, you know what? To make life easier, let's go ahead and just do it here. So do ls, let's do nano, and then let's just do db 10 tab, enter. So this is what it looks like right now. We can remove all of this because we don't want it to look like this. Again, it's already set up for you, so it's pretty much easy. So you can just go ahead and enter that here. But just to clean things up, I'm going to copy what I have. And again, it's very similar. If you want to, you can just leave this as is, or just change a couple of things here, of course, if you need to. But again, I already have that, so there's no need to redo it or recopy it. So I'm going to get rid of all of this guy and just put that guy in there. So again, very similar to our forward zone file, DNS forward zone file. Again, just you have the SOA, you have your domain here. DNS test is the authoritative DNS server, and then you have the email, which doesn't exist. You have the serial, same concept like we talked about. They pretty much mean the same thing, right? And then here, of course, again, you have your DNS, which is the authoritative DNS for this environment. One of these days, I'm going to say authoritative, right? And then here, this is what I was talking about, right? So now we have our PRT record. So if you remember in our zone file for our forward zone, we had our A record. In here, we have our PRT record. Again, here we only need the last number of our IP. Again, because it's a reverse lookup, it start looking at it from the back and then move to the to the rest of the IPs. So to the rest of the numbers in your IPs. So it's going to start 3.100, and then it goes .10.10. So all we need basically is this number. So basically we're associating and say like, hey, this IP address belongs to this name, right? So similar to what we did when we're saying that this name, right, belongs to this IP address. Now basically we're saying that this IP address belongs to this name. And that's what a PRT record is. So that's pretty much all we need to do. Just make sure your config is perfect. Make sure it reflects the things that you have. Make sure all of this is correct. And then all you have to do is just Control X and then do Y and then click enter. So now if we do 9 one more time, I don't want to go into it actually, so I'm just going to do cat. You can see that that is pretty much good to go. So those are the two things that you need to update. Again, very similar to our forward zone. The reverse zone is very similar, just a few changes. PRT record, a record, and the zone name is a little bit different. We need to make sure we restart the services after making those config changes. So we're going to do systemctl restart BIND9. So we want to restart the services and just make sure it's working. Yes, okay, it's up and running. So now if we want to do a reverse lookup, we're going to use the dig command to try to see and make sure everything is working. So we're using the dig command, and this time we're using -x, telling dig to do a reverse lookup for this guy on this guy. So it's the same server because I don't have anything else set up right now, but it's basically telling it like, hey, do a reverse lookup on this server for this IP address. So if we click enter, if everything is set up correctly, we should be able to see that everything works. So if we click enter, as you can see, no error, everything works. It gives us the time and it tells it that yes, there's a reverse lookup. And if you notice, see how we put the 3 in front of that. So it's 3.100.10.10, which again, it's reverse. So all we needed was the 3, and it's able to find it, and it's telling us that like, hey, this IP address basically belongs to this guy. So again, everything is working correctly. Now we have our reverse lookup set up. We can query things and be able to say like, hey, who exactly is this IP address belong to be able to tell us. We can also query and say like, hey, what is the IP address for this particular name? It'll be able to tell us as well, right? So we have everything set up. And that's pretty much how you set up your reverse zone in BIND9. Next thing I want to talk about, but I'm not going to set up, is Dynamic DNS. So Dynamic DNS basically lets clients update their own DNS record automatically, which is great for big networks with a lot of changing devices. You usually tie it to, let's say, your DHCP server. So when it hands out an IP address, it can notify DNS to update the records. I'm not setting it up right now because first, my lab isn't that big or is not big enough for me to really want to set it up. And then second, doing things manually will help me learn more and keep my DNS record clean and easy to manage. However, as my environment grow past a certain point, I'm definitely going to be adding or configuring Dynamic DNS. Your DNS server can act as a forwarder, which just means it passes requests to another DNS server, kind of like a middleman. Or it can act as a recursive resolver, which means it starts from scratch and figures out the answer itself by following the entire DNS hierarchy. When working recursively, your DNS server starts with what's called the root server. There are 13 main root servers spread across the wall, and they act like the highest authority for DNS. Your server will use a file called root hints, which lists those 13 servers. So it knows where to begin asking questions. From there, it would work its way down, first to the root server, then to the top level domain like .com or .net, which are basically the last part of a domain name, then to the second level domain like Google in google.com, and then finally to the authoritative server for that domain, meaning the server that actually holds the official record for the domain until it finds the final answer. In my lab environment, I'm setting up Bind in recursive only mode. So it will resolve everything on its own without relying on another upstream DNS server. Now, the next thing that we want to do is that we want to make our DNS a recursive DNS. Basically, what that means is that we were trying to prevent our DNS from being a middleman, meaning that if you were to ping something like google.com and our DNS server can't find google.com in our local zone configuration, our zone file configuration, it will need to contact something like Google's public DNS or Cloudflare's public DNS to be able to see like, hey, I can find this. Can you guys please go ahead and check the root DNS for me and see if you have it and then send it to me? We don't want that to happen because with that, it's a bit of a security thing too, depending on how paranoid you are. Some of those queries get sent up to those public DNS, and you don't know if they're saving those. You don't know what they're doing with those. So you sometimes don't want that. So depending on what you're setting up your environment for, you want to lock things down a little bit. So the first thing that we need to do, if we do ls here, let me do ls. Now, one of the things that you're going to notice is that we do not see the db.root file. The db.root file, like I said earlier, is the file that we need to create that is going to hold all of our hint, like it's going to be our root hint file. Basically, it's going to hold all of the 13 root DNS servers that our server will be able to look at if it needs to query something without looking at our public DNS, which is Google and Cloudflare. So to be able to create that, I'm going to go ahead and just copy this command in because it's a pretty long one. We're basically just going to grab those 13 the root DNS server. So basically what we're doing here, let me move that. We're basically doing wget to grab it, right? And then we're grabbing it from here, right? And you can navigate to this to check it. But we're grabbing it from here and we're pulling it down, and this is what we're calling it, the db.root file. So as you can see, just to kind of show you, I'm going to go back a little. Right, and I'm going to do ls one more time. That file currently doesn't exist. So if I paste that back in here and then just click enter, you can see wget went and then grab it. And now if we do ls, you're going to see that that file now exists. So if I was to do cat db.root, right, now you can see these are all the 13 root DNS server that we talked about earlier. Again, this is what it means to be a recursive DNS server. It basically has all of this root DNS server. So every time you query something that's outside of your zone or that's not in your zone file, it will query this DNS servers directly, which are the root DNS server, instead of querying a third-party DNS server like Google or Cloudflare to say like, hey, you guys go check the root DNS server and then bring me back that information. So you kind of skip the middleman, so to speak, and then just go straight to the root server and say like, give me that information and I need it. So that's the first thing that we need to do. Next thing that we need to do is we need to configure this guy right here. This is where we configure a lot of our configuration that have to do with whether or not we want our DNS to be recursive, whether or not we want it to only accept query from specific files. So let's go ahead and take a look at it. So if we were to do nano and ANO and then do name.conf.option and then click enter. So right now it looks something like this. It has comments. So what I'm going to do, I'm going to use VS Code to navigate to this file. And then we're going to make a lot of different configuration changes, and we're going to talk about it. So let's switch over. Okay, so we're back in VS Code now. We're going to go ahead and open that config file. So it took me to the root. I'm going to go to etc here, go to bind, and we're looking for the option, name config.option. And this is what the default look like. I'm going to go ahead and remove this so I can input what the configuration should be. And again, keep in mind that this is reflective of what you want your environment to be set up as. I am going to include some configuration and talk about them. And then, of course, you can always update this, add things to it, and make it look exactly the way you want it to look. So for now, basically, this is the option. It's a very simple option, but it gives you a lot of security and it gives you a lot of validation, and it makes things a little bit simple. It's not overcomplicated, but again, you can add a lot more options and a lot more config to this file, right? So the directory, this is, of course, is the bind directory. And here is saying that, do you want this DNS to be a forwarder? In this case, it's commented out. I said no. If you do want it to be a forwarder, what you would do is you will uncomment this, and then you will add the public DNS that you want your DNS to forward your request or your query to. So in here, you will add something like 1.1.1 or 8.8.8. Or any other DNS that you want your DNS server to forward your request to. And here, basically, you're saying that like, hey, I want my DNS to only respond to queries from a particular subnet. This is a good way to kind of lock down things a little bit, so your DNS doesn't get queried from like different subnets and things like that. So if you need a little bit more security, you can lock things down this way. And the same concept go for here as well. So all recursions, you're saying that like, hey, I want it to only come from this particular subnet. In our case, is the subnet that our server is on. So it's our VLAN subnet for the test environment. So you can add whatever subnet you want here. And of course, you have to put it inside of the notation as well. So something like this. All right. And then here we're saying that recursion is yes, meaning that we want this DNS server to act as a recursive DNS server. And then you have this, which is DNSSEC validation auto. Basically, this just basically helps to ensure that the data you get from DNS has not been tampered with in transit. So it's just basically a security feature here. Always good to turn that on. And then here we're locking things down. Instead of listening on your whole subnet or listening across your whole subnet, you can just make it and say that like, hey, I only want you to listen on this particular IP, which is basically the IP for the DNS server. So again, a bit of a security there. So most of the things that I've added is just for a security measure. So you can add that as well. But if you want to make it a little bit broad, you can remove that and make it listen on whatever it is that you want it to listen on. Right. And then of course you have something like IPv6. If you wanted to listen on an IPv6 address, you can turn that on. In my case, I don't use IPv6 in this environment, something I actually need to start looking into, right? Because there's very few people that actually know how to use IPv6. It's one of those things that's still being ignored. So something I'm definitely going to dive into a little bit later down the line. But anyways, this is kind of like the basic configuration for the name.config option. We're enabling recursive. We're telling the DNS server to like, hey, you're not a forwarder here. And then we're telling like, hey, do a recursive search, meaning that you go and then contact those hint, our main servers, our root servers, look at the hint file, contact our main servers, and then get the information that you get from there. Don't forward it. As you can see, this is commented out. Don't forward it to any other DNS server. Do not become a middleman. You are the main man. Just go and do recursive search and then bring the information back down. So that's pretty much how we configure this. Because I'll have this config file on my website, and I'll try to include it below too. I don't want to make the description too long, so most likely it's going to be on my website. But once we have this fully set up, this is how we will set up our server as a recursive server. Once we have this fully set up, all I have to do is just do Control-S, which saves it. And in your case, if you're doing it on the terminal, you can do, if you're using Nano or Vim, whatever it is that you're using, you can do the options there to save that and click X. And that's pretty much it. And this is how we configure our server to be a recursive server or to be a forwarder, right? So if you want to forward it, again, I don't mean to sound like a broken record, but if you want this DNS server to be a forwarder, all you have to do is just enter those things here. If you want it to be a recursive server, you would disable this, comment this out like I did, and then you would tell it like, hey, I do want you to be a recursive. You want you to perform recursion, which means that you're a recursive server, and that the answer to that is yeah. Yes. All right. So we're back in the terminal. Just so the changes that we made take effect, we need to make sure we restart the bind server. So what we want to do is just do sys system ctl restart the BIND9. So we're just going to restart the server, and then we're going to check the status just to make sure it's running. status. And it's up and running. So now if we do ls one more time, we should be able to, I'm just going to cat name option, and there's the changes that we made. So now this changes should have taken effect now, and the query, we can only query from our VLAN subnet, and all the other changes that we made should have taken effect now. So that is pretty much how we configure our server to be a recursive server and not just a middleman and forwarder. All right, so that's pretty much it for this video, guys. So like I said earlier, DNS is one of the most important services in your environment, and one of the first thing you want to make sure is working correctly. In our case, our DNS server should now be up and running, configured in a recursive mode. Every time you set up a new server, you will need to create an and PRT record for it, so you can reach it by using its FQDN or its IP address. And you would do this because, again, it's not dynamic DNS, so it doesn't automatically create this record, but you will have to manually create the records for each and every server that you set up. And again, this is good because it allows you to really get to understand how DNS work and what are some of the different type of record. There is a lot more you can do to refine and improve your DNS server, but this video should have given you like a really good solid starting point. In our next video, we'll move on to setting up another core service, our certificate authority, that would help us secure data in transit and get rid of those annoying SSL errors. Like and subscribe and stay geeking as always. I will see you guys on the next one. Peace.